Hello everyone, my name is Isabella Shen, and today I will be talking about binary search. When to use. Binary search is efficient at finding an item in an already sorted list or array. If it is unsorted, you will get a wrong answer. In the case of large datasets, binary search is even more effective. This is because each time binary search will halve your list, so it doesn't really matter how big your list or array is. How to use. Binary search follows a set of pretty easy steps. Step 1. Find your target. Your target is the item you are trying to find the index for. Step 2. Find your midpoint. In order to find your midpoint, you have to know the indexes of your list or array's lowest value and highest value. Your midpoint is equal to the index of your lowest value plus the index of the highest value divided by 2. Step 3. Compare. If your item is equal to the value at the midpoint, you have already found your answer. If not, you have to keep going. If your item is bigger than the value of the midpoint, you will be working to the right of the midpoint. The index to the right of the midpoint will be your new lowest value. It's like creating a new sub-list or array. If your item is smaller than the value of the midpoint, you will be working to the left of the midpoint. The index to the left of the midpoint will be your new highest value. Step 4. Repeat step 2 to find your new midpoint. Step 5. Compare again. If you have found your answer, you are done. If not, keep repeating those steps until you have reached your target value and found its index. Now let's try a code example. In this example, I'll just be trying to find an item in an array. First, we have to define and declare our array. I've listed a couple of numbers here, and I'll be trying to find an item in it. Now, we have to create our binary search function. In this binary search function, we will be using our array and our item, which we'll get from our CN. Now, let's declare and define our start point. Our start point will always be 0, because it is the first number, essentially, in our array, and that will always be 0. Next, our endpoint. The endpoint is just the last index in our array, which is equal to the length of the array minus 1. We have to subtract this 1 because we start at 0. Next, let's declare a middle point. We will define it later, but for now, we will just keep it like this. Now let's create our while loop. While our start point is less than the endpoint, this part has to be true, because if the endpoint were to be bigger or equal to the start point, it wouldn't really be an array. Now, it is time to define our middle point. Our middle point is equal to the start point plus the endpoint divided by 2. It's basically in the middle of the 2. If the value at the middle point is equal to our item, we have already found our answer, so we will return the middle point. Else if our item were to be smaller than the value at the middle point, we will be working to the left of the middle point, basically forming our new subarray. That means our endpoint now is equal to our middle point minus 1. It's one index to the left of it. Else, our only other option is if our item were to be bigger than the value at the middle point. So that means we'll be working to the right of the middle point, forming another subarray. In this subarray, our start point will be the middle point plus 1 index to the right of the middle point. If we were to run this, we would get the correct answer. If I were to enter 5, you would get 2. Enter 6, we would get 4, and more. That is all for today, and thank you for listening.